All right, you're talking about WebAssign or the special homework?
I have both, but WebAssign, the only thing that I'm confused about is the statements about the knights and the knaves.
Ah, about the knights and the knaves.
Yeah, a knaves, yeah.
Ah, that's a fun one. Shall we look at that one first?
Yes.
Okay, I'm going to share my screen and we're going to take a look at the WebAssign.
It's question 7.
Okie dokie. And that's section 2.3, right?
Yes.
Okay. I'm going to put it on the student preview so that all the answers don't show up. Do you understand that the knights always tell the truth and the knaves always lie?
Yes.
Okay, so web assign section 2.3, number 7. So one of the ways to approach this problem is
Mhm.
to understand that there are situations that we can express in a truth table, and A can be like P, and B, the night that's B, can be like Q, and then we can go through and try to figure out what's going on using a truth table. All right, I'll show you what I mean.
All right.
Hang on. Am I sharing my screen? I'll
Yeah.
stop sharing. So there's the problem. We want to figure out what A and B is. We'll do part A together. All right. So uh night A says both of us, excuse me, native A says both of us are, what does A say? Both of us are knights. Okay. Both of us are knights. And native B says A is a knave. Okay. And we're going to try to figure out what's what. So I pinned this. Can you see what I'm writing? Okay.
Mm-hmm.
All right. So let's just think about it. We can put true if A is telling the truth. That means A is a knight. And true, true, false, false. And under B, we can say either B is a knight or B is a knave, right?
Mm-hmm.
Because true is the same thing as telling the truth. So that would be a knight, and false
Name would be
would be
name.
a knave. Uh-huh. Yeah, the K is silent. Um, so let's just go through row by row and see if the truth assignments for A and B could possibly work out given what they say. All right, for example, in row 1, A and B are both knights, correct?
Mm-hmm.
Because they're both telling the truth. Well, A says both of us are knights, and that would jive with A telling the truth.
Mm-hmm.
So if we call this statement 1 and this statement 2, statement 1 is okay in row 1 because it jives with both of them being knights and with A being a knight and telling the truth and saying we're both knights. But A1, B has to be telling the truth.
Mm-hmm.
So in row 1, A is a knight and B is a knight. So B has to be telling the truth, but B says A is a knave. So the statement 2 can't possibly work out in row 1 because if B is telling the truth, then it's true that A is a knave, but that's not what's happening in row one because A is a knight in row one. You see?
Mm.
So row one can't possibly be what's going on. Hey, Abu, we're looking at the knights and knaves problem in WebAssign. All right, let's take a look at the second possibility. In the second row, A has true, so A is a knight and is telling the truth, and B has false, so in this row, B is a knave. Let's see if that can work out. Well, A is a knight, and A always tells the truth. But A says both of us are knights. But in row two, then they are not both knights. Only A is a knight, so it can't be true that both of us are knights because B isn't a knight in row two. But what
Mhm.
A says has to be true because A is a knight in row two. So this first statement is going to
Mm.
fail. So that's not possible. You see what I mean?
Mm.
Now you tell me, in row three, what is A in row three according to our
A is like knave.
good,
Um, uh, B is like knight.
great. So A is always lying and B is always telling the truth. Okay, so let's look at A's statement. A's statement has to be a lie in row three, right?
Hmm.
Well, what is the negation of both of us are knights? Because this has to be a lie. That means this statement's negation is
It
what
would
is true. So, what's the negation of both of us are knights?
either one of us is a knight.
That's right. And one of us is a knave, or both of them are knaves. So either one of them is a knave, or both of them are knaves. So far, one is okay because we know that in row three, A is lying, and that's a lie. Now let's look at what B says and compare it to what should happen in row three. B
B
says
is
A is a knave. Now in row three, is that supposed to be true or false?
true.
And look, in row three, A really is a knave because A is telling falsehoods in row three. So two is okay as well. Both of these statements work out in row three. So it looks like it might be row three. Let's check row four. Again, A is a knave and is lying. So that works out. Both of us are knights is a lie. And that's true. They're not both knights. In fact, they're both knaves. So statement one is okay because we know A is lying in row four. What about statement two?
It's a lie.
It's a lie in row four, but if it's a lie, what would be true?
That is a knight.
Yeah, and we know in row four, A
That
is a knave. So statement
fails.
two fails because B has to be lying in row four, right? So one, two, and four are impossible. That only leaves us with three. It must be that A is what?
It must be that A is a knave.
That's right, because in row three, A is telling things that are false. That means A is a knave and B is a knight. That's the only way that the two statements are of the correct truth value. Hang on, I've got to do something. Hey, Rocky, stop. 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 My dog was stealing the cat food. I had to pick it up. He's a thief. He's always hungry. Okay, so you understand that this is one way to try to approach it
Mm.
is by using a truth table and just going through line by line and checking the statements against the characters in that row, right? And I'm going to share one more time and we can look at this problem again because, okay, problem B is very similar, except only C speaks, but you can still figure it out. On problem C, we've got relatives or natives E and F, and they both speak. And it turns out that you won't be able to figure out which one of them is a knave, but I think one of them will be a knave and the other one won't, but you won't know which. That means in the truth table, rows 2 and 3 are possible. They're both going to be possible, I think. I think that's the way that turns out. And then when you have so many natives, like in the last problem, you may not really want to make a truth table. What you may want to do is just go in here and start comparing what they are saying. For example, you says none of us is a knight. Now, if that's true, then that means you is not a knight either, which means it's not true that none of us is a knight, and at least one of them must be a knave, okay? And, that would jibe with what W is saying.
Well, how would we do a truth table for this?
Well, it would be too big. You could do, how many rows would a truth table have if you have 6 variables, U, V, W, X, Y, Z?
24?
2 raised to the 6 is bigger than 24.
Oh, 2 raised to the 6. Oh,
I think it's like 64.
oh,
Yeah, we don't want to do it that way.
okay.
But you do know a couple of things. You know for sure that each one of them is either a knight or a knave, right?
Hmm.
And some of these statements will reveal what that person is. For example, let's look at this very first statement. You says, none of us is a knight. All right, well, either that's a true statement or it's a false statement. Do you agree?
Hmm.
If it's a true statement that none of us is a knight, that includes you. It's saying you is not a knight either. And that means that this statement must be false because you must be a knave if he's not a knight. See what I mean? So it's impossible for you to be a knight and say that.
So he's a knave.
He must be a knave. So you can make a note of that. For sure, you is a knave. So he's lying. Now, we can, knowing that there's at least one knave for sure, we can compare that with some of these other statements and see if any of these other statements reveal something. Just knowing that you for sure is a knave. Okay, well, V says at least 3 of us are knights. That's possible with you being a knave. W says at most 3 of us are knights. That's possible with you being a knave. Like we know you as a knave. X says exactly 5 of us are knights. Well, that's possible with you being a knave. Okay. And so is what Y says. And so is what Z says. They all jibe with you being a knave. So we can't really milk the fact that you is a knave much further than we already
That
have.
means V, W, X, Y, and Z are knights
Well, let's see. How did you come up with that?
because U is the knave.
Well, but we don't know that all the other, just because U is a knave, that doesn't mean all the rest of them are knights. For example, look at what V says and look at what W says.
At least three of us are knights. At most, three of us are knights. That means the most is three knights.
Well, if W is a knight, then this is a true statement. But what if W is a knave? Then V might be
A knave.
a knight or a knave. You see, my point is this: can V and W both be telling the truth?
No.
Are you sure?
At least at most, at least at most, at least, at least at most, yeah,
How could they both be telling the truth?
that there's three knights.
Uh-huh. It's possible that there are exactly three knights. Do you agree?
Yeah.
If both V and W are telling the truth, then they are both knights, right? And that's
Mm-hmm.
two of the three.
Mm-hmm.
That means there can only be
One last night.
one more knight.
Also, Z would be one because you said exactly one of us is a knight.
Well, no, no. If V and W are both telling the truth, we have to have exactly three because at least three means three, four, five, or six. At most, three means zero, one, two, or three. The only way they could both be telling the truth, that means they are both knights, is if there are exactly three knights, and here are two of them. That's assuming that V and W are both knights. If they are, then there must be one more knight. Well, we know U's not a knight. And if V and W are knights, that means there are exactly three knights. And that means X can't be a knight because exactly five of us are knights would be a lie. Says exactly two of us are knights. That would be a lie if V and W are knights, because if V and W are knights, there must be exactly three. And Z would also be a knave and lying because that doesn't jive with what
Mhm.
V and W are saying. And now we realize V and W cannot possibly both be telling the truth because if they are, then they are the only two who are telling the truth. And that means what they're saying is not true.
Mhm.
But it is possible that at most three of us are knights. And it, right? I mean, let's look at what X, Y, and Z say. X, Y, and Z are contradicting one another. Do you agree?
Mhm.
Of the three of them, X, Y, and Z, how many would be the most that could be telling the truth? What is the maximum number of X, Y, and Z that could be possibly telling the truth?
Um, five.
No,
Eh,
no. I'm just talking about if we only look at X, Y, and Z and what they say.
Two, exactly five of us are knight. Exactly two of us are, one of us is a knight. Uh,
Do you see how they're saying different things? And
yeah,
they they can't all be telling the truth. Could they all be lying?
yeah,
They could all be lying. And in fact, one of them might be telling the truth, but no more than one of X, Y, and Z could be telling the truth. Because if one of them is telling the truth, then the other two have to be wrong and lying. See what I mean? So maybe none of these three are telling the truth, but maybe one of them is telling the truth. We just don't know which one. And we know that of V and W, it's impossible for them both to be telling the truth. They cannot both be telling the truth because if they're both telling the truth, there would have to be 3 nights exactly, and that doesn't work out because there's nobody else that could be a knight. So we know one of V and W has to be telling the truth. How do we know that one of V and W must be telling the truth? Why can't they both be lying
Because they're both saying that it's at least would be at least three, and at most would be three
or more?
more.
At most, oh, no, sorry.
Is
At
this
least three means 3 or 4 or 5 or 6, right?
mm-hmm.
At most, three
Only three?
is 0, 1, 2, or 3. Okay. But if he's telling the truth, then he's one of them.
Oh my God, this is
So, right. So I'm kind of thinking maybe double, let's just go with the idea that maybe W is telling the truth. And that means there's 1, 2, or 3 nights because if he's telling the truth, he's a knight, right? See, if W is telling the truth, that means W must be one of the knights. So there could be 2 more. But the thing is, if W is telling the truth, and we know there can't be exactly 3, we know V is lying, we know U is lying. If W is telling the truth, then can any of these be telling the truth? Yes. Z could be telling the truth. No, if Z is telling the truth and W is telling the truth, then there are exactly 2 nights, so Z would have to be lying. So Z cannot be telling the truth at the same time as W. But I think Y could be telling the truth and W could be telling the truth because at most 3 of us are knights, could be true at the same time that exactly 2 of us are knights is true. So I'm thinking maybe W and Y could be telling the truth and then everybody else is lying. I think that would work out.
Can you try it to see if it works?
Does it make sense?
Yeah, because if it's two, what's the question? So,
Yeah, that's it.
yeah, because if it's two that are nights, and that one is saying at most 3 of us.
And that could be true at the same time.
Yeah,
That's right. Two,
most three.
exactly 2, and at most 3 do
Yeah,
not contradict each other.
as long as it's not more than three.
Right. And we know that if W is telling the truth, V has to be lying because we've already figured out there cannot be exactly 3 nights. There can't be 3. So it's just I wouldn't use a truth table for that. You could theoretically use a truth table for that, but it would take forever. Okay, shall we move on to special homework?
Yeah.
Abu, you've been here for a while. It's your turn to ask a question. Do you have a question?
Yeah, well, I was actually here about uh, this famous, it's called,
4 famous argument forms?
hmm.
What about it? Do you want to look at the notes?
Yeah, I got the notes.
Let's look at the notes. You see the notes are pretty good on this because they're all right there. Okay. See that? All right. So they all have two premises, premise one, premise two, and of course they all have a conclusion. They're very similar. And there are two of them that are valid, and the two that have the Latin names are the valid ones. Notice premise one is the same for all of them. The first premise is if P then Q for all four of them. See? And then they have different premise two and different conclusions, but all of them kind of hinge on the three sisters, the contrapositive, the converse, and the inverse. Remember, and it was written right here, if P then Q is logically equivalent to its contrapositive. So if P then Q is logically equivalent to if not Q, then not P. And that's why the second argument form is valid. Because if we know that if P then Q is true, and we know that we have not Q, then we know we're going to get not P. Because if we have P implies Q, we know that not Q will force not P. You see, that's why it's valid. Have you tried our algorithm to test the validity of these four famous argument forms?
On truth table.
Yeah, let me show you. Okay, so for example, I've pinned this so it's big. Does it look big for you all? You can pin this window and make it large. I've pinned it for the recording. All right, so for example, one of the argument forms is 2, and it's modus tollens. And the form looks like this. If P then Q, not Q, therefore not P. Now, if we want to check that that really is a valid argument form, we can use a truth table to check the validity.
Oh,
Remember how we did it?
yeah,
We make a column for each premise and a column for the conclusion.
yeah. I'm able to do that. The only problem is, like, how do I, know that this one's, not modus tollens?
Oh,
But I'm
so
able to do the truth table.
okay, so you have to make a key. You have to make a key for each of the problems. Let's take a look.
Yeah, but so I can see, right? And I can see the phrases or the sentences and then put it in a statement form, or the statements I meant to say, and then put it in a statement form. But then I can't tell if this is modest, you know.
So which one is giving you trouble?
Well, the first one's kind of easy. P implies Q, P, and Q. And then after that one, it's just, so do I have to just like try to memorize the, uh,
Oh,
how,
so are you worried about remembering the names of the argument forms?
yeah,
Yeah,
like,
yeah, you do.
yeah,
But it's not that bad because converse error and inverse error, their names should be sort of given away by the form. We know that P implies Q is always the first premise, right? Do you know what the converse of if P then Q is?
Q, the opposite. Q implies P, right?
If Q then P, right?
Yeah.
So put the Q here and therefore the P. See,
Okay,
it's,
so that's how it goes.
yeah. And what's the inverse of if P then Q?
That's not what, not P and not Q. No, that's
N-
the that's
not P implies not Q. It's not an and, it's an implies.
mhm.
But that will help you remember these two. And the modus ponens, well, I know that you're going to have to remember that and modus tollens. Okay, so you have to remember the word ponens and tollens. But modus ponens, you can just, you learned languages, you know. This just means straightforward, and tollens means backwards or the roundabout way. So modus ponens is just very straightforward. If you know that P implies Q and you have P, you're going to get Q. And modus tollens just leans in on the fact that if P then Q is logically equivalent to its contrapositive. And you see, that's if not Q, then not P. So you actually can memorize those, I think, if you don't stress too much, just make some flashcards or something if you need to. But they all look very similar.
Yes.
You were in lecture on Thursday, right? So you
Yeah.
heard, so we talked about, you know, these forms and why they're called what they're called.
Mm-hmm.
So sometimes we just have to remember something. But you can
Okay.
look at the notes when you're working the problems.
Okay.
Was
Okay.
there a particular argument that was giving you trouble from the special homework or no?
Uh, Not quite. The last one, just you know,
Argument three?
yeah.
All right. Well, the interesting thing about argument three is it's an argument about arguments. Okay, so what does it say? It says if the argument is not sound, and that's the complication because we have the word not here, then the argument is not valid. So you have to make a decision about your key. Are we going to include the not or are we not going to include the not? But once you make that decision, it should work out either way, no matter whether you make your key with the not or you don't, right? So when you make your key, you know, we want to make a key, right? We want one of something to be P and something to be Q. So what do you want to take for P?
Well, I just had the argument is not sound.
That's fine. The argument is not sound. And then Q was the argument is not valid.
Yeah.
All right, that's fine. And you know, you can do it that way. The other way you can do it is just to let P be the argument is sound, and then this would be not P implies not Q. But this is actually easier. Okay, great. So now let's write, so this is A, make the key. Now let's write the argument form using the P's and the Q's. So what would the first, so we've got what? Premise one, premise two, and a conclusion, right? So
Okay.
what's your first premise?
Negation P implies negation Q.
Well, if you're putting the not in with the P, it's not, it's just P implies Q. Do you see? You told me you wanted your key to be that P represents the argument is not sound.
So
But if you want instead to make the key be the argument is sound, if you want to do that, you can, okay? And in that case, the first premise is not P implies not Q. You can do that. Then what's the second premise?
So the argument is valid, so that's Q.
That's Q. And then what's our conclusion?
P.
P. All right, so that doesn't look like one of our argument forms until you realize this. Just group not P together and think of it as another letter. And group the not with the Q and think of it as another letter. Now, Q is actually not Q, isn't it?
Mhm.
And then you have not P. So what we have is hypothesis implies conclusion, not the conclusion, therefore not the hypothesis. Hypothesis implies conclusion, not the conclusion, therefore not the hypothesis. You see?
So is it Mojis tolerance?
It is.
Oh,
But it might actually be easier if we used the key that you said at first. If we use the key where P is the argument is not sound and Q is the argument is not valid, then the form looks like this. It looks like P implies Q, right? Because
Mhm.
P is not sound, Q is not valid. And then what's the second premise? The argument is valid. Well, that's the negation of the argument is not valid, right? The argument is valid is the negation of Q and then not P. So you can do it that way as well.
So this is it, does this not look like a contrapositive? I don't know.
That's right. It's modus tollens.
Oh, okay. So more stones is like a contrapositive. If I-
Hmm.
uh,
So this was a little bit of a mind bender, right? Just for fun, to help you understand that, well, one, if you did it the first way, you have to just realize that Q is the same thing as not Q. And then you have to group these and realize this is the hypothesis, this whole thing is the conclusion, this is the negation of the conclusion, and this is the negation of the hypothesis. See what I mean? Or if you did it this way, it turns right out, but you have to understand that the statement, the argument is sound, is the negation of the argument is not sound. And the argument is valid is the negation of the argument is not valid. See? I said those in the wrong order, but here's the problem right there. Does that help?
Yes, yes, yes.
Other questions from special homework 3 or other questions?
For
I
me,
do have a question again too.
Okay, it's Karen's turn. Go for it.
Is the biconditional one?
What about it?
Is the question three?
Yeah,
Question two, sorry.
yeah, what about it?
Question. So basically, I was confused about how you want us to do the logical equivalence with it.
Well, you just need to figure out which of those statements are logically equivalent to the given biconditional. Let's take a look at it. The given biconditional is this statement.
Last class was day 4 or day 5?
What?
Last class, was it day 4 or day 5?
I don't know.
Oh, okay.
I know we did section 2.3.
Okay, okay, I
I
have it.
think the very first day of class I called day 0. See what I mean? But this is section 2.3 material.
All right.
No, wait a minute. It's section 2.2 material. My bad. It's arguments, the conditional and biconditional. Section 2.2. So this would be from section 2.2, notes. You can always search in the ebook and just search the word biconditional, but here I can also show you something that might help you. Let me share my screen. If you go to our reading page, you see how it tells you day 3, we worked on conditional
Yeah,
statements, and I give you the section. So this should help you. You can
all
also
right.
look at the table contents in the book, right?
Yeah.
All right. So, all right. Let's take a look at this. Let me give you a hint on how you can easily, well, not easily, but more easily do it. Am I still sharing the screen? Let me stop sharing. All right. So this given biconditional says what? The moon is full. What does it say?
The moon is full if and only if the wolves howl at midnight.
Okay, the moon is full if and only if the wolves howl at midnight. So one of the ways to attack a problem like this is to parse it out. What do I mean? We can let P be the statement, the moon is full. Okay. And Q can be the statement, the wolves howl at midnight. And what we have is a P if and only if Q. Do you agree?
Yeah.
So we make a key. P is the moon is full. And we're going to use this key over and over. And Q is the wolves howl at midnight. I'll just say the wolves howl, okay, to make it shorter. Okay. So then we know that, let's just recall the definition of the biconditional. We know that P if and only if Q means the same thing as P implies Q and Q implies P. Do you remember that that was our definition of the biconditional?
Yes.
So when we look at each of the statements that we're trying to compare to the biconditional, the moon is full if and only if the wolves howl at midnight, we can parse them out and see if they can be parsed to give us P implies Q and also give us the converse, Q implies P. I'll do one for you. Okay, A. A says, no, I won't do A because you should be able to do A on your own. Let's do B. Okay, B says, if the moon is full, then the wolves howl and the moon is full only if the wolves howl, right? That, at midnight. I'm just saying the wolves howl. Okay. That's what it says. And what we want to do is we want to look at this statement and see if we are getting both if P then Q and if Q then P from this. So let's take a look.
The first one, the moon is full and the wolves hold, yes.
So
And
that's if P then Q. Do you
yes.
agree? And we have the and.
And the
And
moon
this
is
is the moon is full only
only
if
if
the wolves howl. So let's write the words. P is the moon is full only if the
wolves
Q.
out.
So we have to figure out if P only if Q is the same thing as if Q then P. Right? We've got the if P then Q here. We know for sure that's if P then Q. We've got the and, right? Now we're checking to see if we have the converse. So we have to think about what P only if Q actually means. Let's take a look at the document in the good stuff folder because that's our ready reference. Okay, we go to content and we go to the good stuff folder, chapter 2 material, if P then Q document. All right,
Should we print out this document?
probably.
And can we use it during exams or
No, you have to learn this because this is
um
ordinary English that we're trying to learn. But you can learn it. Look, all of these are different ways to say if P then Q. Okay, all of these to there. Those are all different ways to say if P then Q, okay? If P then Q is the same as Q if P. But look, if P then Q is the same as P can be true only if Q. P can be true only if Q follows. So P only if Q means the same thing as if P then Q. So P only if Q, this actually means if P then Q. It doesn't mean if Q then P. So what statement B gives us is we have if P then Q and, well, we have if P then Q again. That is not the same statement as P if and only if Q, because two copies of if P then Q are not the same as one copy of if P then Q and a copy of if Q then P. So B is not logically equivalent to the biconditional, but we parsed it out very carefully. We wrote only if, right, between the P and the Q here, P only if Q, and then we checked our reference materials. Or you can just try and understand what P only if Q is saying. It's saying P can be true only if Q follows. That's why it's logically equivalent to if P then Q. So this B is not logically equivalent. So it would not be one of the statements that you would write down as logically equivalent to the given original. Okay?
Okay, that was mainly what I was having issues with, so thank you.
You're welcome.
But I'm not gonna lie, I'm still having like a kind of confusion about the knives and the knaves, but I'll go like read the book more to understand a bit, but yeah.
And I'm gonna give you some information since you've taken the time to come into office hours and you've said you're worried about it. I'm not going to give you a question about knights and knaves on test one.
Thank you. Thank you.
It's
Thank
more
you
for
so much.
fun. It's supposed to be sort of just like a fun logic puzzle.
Yeah.
I don't want you to sweat that.
Uh,
This is more important.
yeah.
Okay?
Yeah.
Okay.
Thank you, ma'am.
You're welcome. Thanks for playing. Abu, what's your next question?
Okay. Oh, the thing is, so professor number two, this one that you just went over, right?
Yeah, did that help?
Absolutely, absolutely. So so I just had like say if like the first one, if it was logically equivalent, and then I will say that. But did you want us to write the statement forms as well?
You could do if you want to show the work, um, because that way I can analyze your logic. But I
Okay.
think the instructions did not require that you do that. I just asked that you write the statements that are logically equivalent. But if you want to write each one and parse it out, and then, tell me whether or not it's logically equivalent, that would be the wisest thing to do. And I was hoping somebody would ask about this problem in office hours because it's not something we did in class, yet we did practice making keys in class, and we did look over and talk about different ways to say if P then Q. And this is the sort of thing where we're just putting together different pieces that we learned to try to apply to a new problem.
Number one. So for question number one, that's just one. Okay, so the original and then the converse. Uh,
And the inverse and the contrapositive and the negation. I think problem number one, just pay attention to the directions because in problem number one, part A, you're going to write the statements formally, and that means you're going to write them using symbols, and arrows and operators. And in
okay.
part B, you're going to write the sentences in ordinary English, informally, okay? So it's good to practice both.
I mean, I already did the whole thing, so I'm just making sure that, at least the format is right. And I just have one last question,
Well,
Professor.
please, please.
If, so I see here that you wanted us to include uh, an academic integrity statement.
That's right.
And so do you want that on a different page or?
No, no, I'm so glad you asked. Here, let me show you. Let's say that these are our problems and we've got them all in order, right? And then we take a blank page, a cover sheet, okay? So here's our cover sheet. In fact, let me show people, because people are having difficulty with this whole homework thing. All right, so put your problems in order, right? Then you just put the cover sheet on top. And then we staple it up here in the upper left corner, right? Then you fold it. Right, so now it's folded. The staple is here, right? And it's folded. This is the right side. So on this side, you're going to write your name. You're going to write 263 and then whatever section number is, and then special homework number 3. And then right below that, you're just going to write, I have not used any unauthorized online resources. The work herein is entirely my own. And then you're going to sign it and you're going to date it. Okay, so you can just put it like that. Does that make sense?
Yes, absolutely.
It can just go right there. And see, and then I still have plenty of room to write stuff here and put your grade up here. It's not going to take that much room. Okay.
Okay.
I'm so glad you asked about that. Can I help you with anything else?
No, I was just looking at what you have there is entirely.
I mean, when you write this or two sentences, it's representing more than you're writing. I didn't want you to have to write that whole long explanation, right? I mean, there's just a long, here, I'll show. There's a long explanation, in this of what you're really
Yeah,
saying. You're saying by writing and signing this statement, you're affirming you didn't seek solutions from Google or Chegg or Course Hero or any other service, including any AI program. You are also affirming you did not seek solutions from a tutor or from a student who took this course previously. Because some of these solutions, probably are out there, but it doesn't do you any good to copy those. The value of these homeworks is that it teaches you to concentrate and think more deeply and spend more time and read the instructions and try to sort things out on a deeper level.
well, I mean, that was everything for me, Professor.
Thank you so much for coming into office hours. I'm so glad that you did.
Yeah, thank you for having me, Professor. Have a good night. See you tomorrow.
You as well. Good night.
Okay.